Now that we've got an understanding of some of the basics of how Python works, let's start putting it together to see if we can model the simple fly that we talked about earlier. You may remember this bit of an algorithm we looked at earlier. We don't need to go through all the details, but the basic idea was that the fly had some state, for example, whether it was scared or hungry, and it sensed some input. And then based on what it sensed and what its state was, it would do something. All right, let's see if we can program that. We'll go to PyCharm and we will make some variables that define our fly's state. Why don't we start by giving it a name? I'll call it Buggy. And we'll make one variable for each of some of those things. For example, is it hungry? No, not now. But if we want to make it hungry, we just change that to true. Is it scared? Well, maybe it is scared right now. Is it currently flying? No, it's just sitting around. And we'll just make a variable called sense that describes what the fly sees, what it senses. Since we don't have a mechanism to give it input yet, we'll say that it senses food. All right, let's start by printing out its current state. So we'll say my name is name. So right, we're concatenating the string with the value of the variable name. And now we're going to keep on going and say, and my flying state is flying. Let's try running this. Oops, and we got an error. Right? It happens to everybody. Certainly it happens to me all the time. So we'll see if we can interpret this. Tracepack file tells you what line the error is on, line 7. Print my name is, so something about this last one. Cannot concatenate string and Boolean types. Right, flying is a bool, and we need to convert it to a string. Fairly common. Try again. Common error. There we go. My name is Buggy, and my flying state is false. Notice how we got the comma and the space right. After the name, I concatenated a comma, then a space, and then the rest of the sentence that I wanted to write. Okay, now we can start doing some stuff. If it is scared, then we'll print something saying what we're going to do. Say we want it to fly randomly, and we'll change its state. We'll say flying equals true. Right? Remember, this is an if statement followed by a colon. These two lines are indented, which means they'll both get executed if it is scared. Then we can continue on, and at the end of this program, I'm just going to copy this line up here and put it again, and we will be able to see if anything about its state changed. We run it. So, my name is Buggy and my flying state is false. We fly randomly, and now my name is Buggy and my flying state is true. So we have modeled something about what the fly, what its state is and what it can do. Of course, we only have modeled it in a very trivial way just by storing whether it's flying. We don't actually have any graphical fly flying, at least not yet. But that's starting to get an idea. Let's go a little bit further. What if it's not scared? Well, then if it's hungry and it senses food, then instead of flying randomly, it can fly to food. So how do we put all those things together? Well, remember there was a Boolean operator called not, which takes a parameter, which is a Boolean, and it turns the opposite of it. So if scared is true, then not scared will be false, and vice versa. So if it is not scared, and it is hungry, and sense equals food. I'm going to put parentheses around all the pieces here so you can see exactly how it's operating. Not applies to scared. We are comparing sense and food. And now you can see more clearly this if statement is going to be true only if this thing and this thing and this thing are all true. So if all three of those things are true, then the following lines will get executed. Copy this. Instead of flying randomly, will fly towards food. Let's try running it, see what happens. Right? Oh, sorry, wrong one. Fly randomly does exactly the same thing because it was scared. Well, let's change its initial state from being scared to not being scared. And now when we run it, we have it doesn't fly at all because it is not hungry. So let's make it hungry. And now try running it. And now it flies towards food. All right, we're making some progress. Let's try one more example. I'm going to copy all this and change it a little bit. If it's not scared, and it's not hungry, and it's currently flying, then what should it do? Well, it's not scared, it's not hungry. In other words, it doesn't have anything to do. It's flying around, it's wasting energy. Maybe it should stop flying. So let's say now going to land and set flying to false. Let's check our input to make all this work. Not scared. Okay, it's not scared. It's not hungry. Set hungry to false. And let's make it so it is flying. Now when we run it, sure enough, it starts off where it was flying. It says it's going to land, and it finishes where it isn't flying. Okay, so we have our first program that models a fly. Let's take this fly program, this fly model, which works just fine, and make it better. Now, I don't want to make it better by having it do more. I want to make it better by making the code easier to understand. This is crucial. When code is easy to understand, it's less likely to have bugs, it's easier to communicate what the program is doing to someone else, and it's easier to update it and add more features later on. One of the things I don't like about the way we wrote this program is that there's these three separate if statements that have nothing to do with each other, as if they have nothing to do with each other, even though they do have something to do with each other. This first one is if it's scared, and the second two are if it's not scared. So there's clearly a relationship, but we're not showing that relationship in the code. Instead, we're duplicating this conditions, right? We have not scared twice, and if we mistyped it or used the wrong variable, we would get something totally wrong. So instead, what I want to do is have a mechanism that says, if I'm scared, do this, otherwise, do something else. And it turns out that the if statement has a matching mechanism that does the otherwise, and it's called else. So after an if statement, if you have an else followed by a colon, then you can have a bunch of indented lines that will get executed only if the condition is not true. So what we can do is indent all of these lines, and they only will get executed in the case that it is not scared, which means we don't have to test if it's not scared anymore. So we can remove that condition. And now, look how much simpler this code is. If it's scared, do this, else, do this. Now, when you just see the else by itself, of course, you don't know what it means. It only has a context. It only has meaning in the context of the previous if. And if the previous if condition was far away, you wouldn't be able to see it, and so the code might get hard to read. So what we sometimes do is add some comments. Comments are text that are designed only for humans. The Python system completely ignores comments, but it can be really helpful to explain to a human what the code means. In Python, there's a few different ways to add comments, but a simple way is just to put it in the pound sign, then everything after the pound on that line and that line only is a comment for a human to read and will be ignored by Python. So we'll just say not scared. And we can test this. It will do exactly the same thing. Right now, it is flying, and it's not hungry and not scared, so it's going to land. We'll just change one of these things. Let's change scared to true and run it. And now it says fly randomly because it's scared. All right, so we're making some good progress here, but I think we can improve it even more, because now when we look at this code, we see that we have a similar kind of thing. If hungry and if not hungry. We could combine these and use an else statement again. But it's a little bit trickier because this if statement is not checking only if it's hungry, but if it's checking if it's hungry and senses food. So what we need to do is pull out the hungry checking and have an if statement that only does hungry, then we can have an else that's not hungry, and then we'll have to do something else. And what we do is we're going to say if hungry, I'll just sort of write the structure for what we're going to do, else not hungry. Right? That's sort of the same model that we had before. Notice this whole thing is indented. It only gets executed in the else clause of scared. So if it's not scared, then if it's hungry, do something else, do something else. When we have an indented if statement inside of another if or else statement, that's called a nested if statement because we're nesting one inside the other. All right, now what we can do is take this part. We know where it's hungry and put it up here, but we don't have to check if it's hungry because we know it's hungry. We only have to check if it senses food. But we only want to do this if it's hungry, so we take this whole thing and we indent it like that. So what this says is if it's not scared, then if it's hungry, then if it senses food, then do this. Okay, else not hungry, and again we'll do something similar. Indent this so it's nested inside this second else, but we don't have to check if it's not hungry because it's inside this else clause, so we know it's not hungry. All we have to do is say if it's flying. Now this code again will run and do exactly the same thing it has before, but even though it's got several nested if statements, I think it's actually easier to understand and certainly easier to maintain as it gets larger and more complex. I think that's enough for fly modeling for now.